So today we're going to discuss about scanning and tunneling microscopy. Scanning tunneling microscopy is a method, and scanning tunneling microscopy is a device that obtains images of an atom on the surface of a material. Okay, so here's the basic layout of scanning tunneling microscopy, and we have these components in scanning tunneling microscopy. We have a metal tip, usually of tungsten, and we have a current amplifier, and we have distance control unit, and we have a distance control unit, and we have display unit. We provide a potential difference between the surface that is to be analyzed and between the tip of the metal. Scanning and tunneling microscopy works on the principle of quantum tunneling effect. Quantum tunneling effect. It says whenever an electron acts as a wave, then it penetrates through the surface. So if there is a surface and the electron is a particle, then it gets returned from the surface. Whenever the electron is a wave, then it gets along with through the particle. This is the main principle of scanning tunneling microscopy, and in the figure it's shown. Basic components of a scanning tunneling microscope are metal tip, which is usually of tungsten. This one is metal tip, and we have current amplifiers to amplify the small amount of tunneling current. We have distance control unit that usually controls the distance that this metal tip moves in the upper part of the surface. Scanning tunneling microscopy helps in determining the surface structures of conductor sample. It has wide application in molecular science, also called nanotechnology. Components of STM scanning tunneling microscopy are metal tips, piezoelectric scanners, current amplifiers, feedback loop. The basic idea is to bring the fine metal tip in close proximity, that is few nanometers, to a conductive sample. By applying the voltage between the tip and the sample, a small electric current can flow from the sample to the tip or reverse. Although the tip is not physically in contact with the sample, the phenomena is electron tunneling. So electrons pass from the tungsten tip to the surface because of the tunneling effect. That is, the electron travel in wave, so they get transmitted. When a potential difference, something volts, is applied between the surface on the study and tip of the tungsten. Tunneling amplifiers help to amplify the current. That is all about scanning tunneling microscopy.